To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter we discussed several questions, several MCQ questions from our extra exercises lesson part. So within this chapter also we'll be discussing several MCQ questions, right? So in the earlier chapter we discussed like 20 MCQ questions. Now from the 21 onwards we'll discuss the next part. So the question number 21, oil floats on water. You know that oil is going to float on water. The most accurate reason for this is it has high density. So if it is floating, my dear children, you know that the floating things have a lesser density. So go for the answer low density. Yes. So the low density can be identified here. It has low density. Oil floats on water because it has low density. Next one. A substance is cut into several pieces. As compared to the density of the original sample, the density of each piece will be less, more, no change, none of the above. Substance is cut into several pieces. Now, we'll imagine that it's a piece of paper. Now, you are cutting that piece of paper into several parts. If so, what will happen to the density of each part? No matter you reduce the volume, now over there you are reducing the volume, no. Over there you are reducing the volume. Even though you are going to reduce the volume, my dear children, if it is the same substance, then the density factor is not going to change. Mass over volume factor is not going to change. So here we can say that even though it is cut into several pieces, compared to the original density of the sample, the density is not going to change at all. Density, no change or no change in the density is our answer. There is no change in it. Next one, 23. Densities for blank and blank do not change significantly at ordinary conditions with pressure. With the pressure, my dear children, you know that substance is going to compress. When you are providing pressure, a substance is going to compress. Upon compressing, the spreaded volume is getting somewhat decreased. That means the density is getting increased. So this can be done to mainly for gases. When compressing liquids and solids, usually these liquids and solids do not get compressed easily. So upon pressure, liquids and solids do not change the density because the volume is not changing upon the provision of pressure. So here, densities for blank and blank do not change significantly at ordinary conditions with pressure. The answers should be, my dear children, for solids and for liquids. So go for the answers that contain solids and liquids. Yes, liquids and solids. So densities for liquids and solids do not change significantly at ordinary conditions with the pressure, my dear children. Next one, density of water is, we know that the density of water, it's very simple. 1000 kilograms per cubic meter. 1000 kilogram per cubic meter is the answer. 13,600 is in mercury. If you indicate this thing by grams, so it is equal to 1 grams per cubic centimeter. Okay, right. Then the next one, standard international unit for density. Very simple, my dear children. The standard international unit for density is kilograms per cubic meter. Kilograms per cubic meter. Next one, to convert the density of kgm-3 into gcm-3, that means to convert density of kilograms per cubic meter into grams per cubic meter, we divide the quantities with 100, 1000, 10,000, 10. You know that density of water is equal to 1000 kgm minus 3. Density of water in grams per cubic centimeter 1 gcm minus 3. So it's very obvious that you divide by 1000, you can get the answer as 1. So to convert densities of kilograms per cubic meter into gcm minus 3 or grams per cubic centimeter, we divide the quantities with 1000. Mass of oil is 11,040 kilograms and the volume is 12 cubic meters. Its density would be 11,040 is the mass and the volume is 12 cubic meters. So let's find out the volume then. So let's find out the density then. Density equal mass over volume. Mass is given 11040, 11,040. Then the volume is given 12. So here kilograms and here cubic meters. So let's divide and get the answer then. 40 should be divided by 12. So here it's 9, 96. So the remainder so here 908. So the remainder is 2. For 24 there is 2. 24 0 for 0 0. So 920 is the answer. 920 kgm minus 3 or kilograms per cubic meter. 920 can be identified in the third response. 920. So I'll erase the workings. Right. Mass is a measure of weight, amount of matter, space occupied, none of the above. So you have learned about the mass, my dear children. Mass is going to refer the amount of substance contained within the matter. So it's referring to a number of particles contained within the matter. So mass is referring to, it is also a measurement of amount of matter, number of matter. Right. Density is not dependent on. Density is not dependent on. Right. Density is not dependent on mass, space occupied, volume, gravitational acceleration. Mass, you know that density is equal to mass or volume. So definitely mass is dependent. From the mass it is dependent. Space occupied and volume, both the things are same, my dear children. Space occupied by a certain object is the volume of it. So but gravitational acceleration, there is no direct relationship between the gravitational acceleration, right? So our answer would be gravitational acceleration, right? So density is not dependent on gravitational acceleration. Next one. Mass of 1 cubic centimeter of pure water is mass of 1 cubic centimeter. Very simple, my dear children. 1 cubic centimeter of water weighs exactly 1 grams. That is why the density is given as 1 grams per cubic centimeter. 1 grams per cubic centimeter. Next one. Volume of glass is 15 cubic meters. And its density is about 2500 kilograms per cubic meter. Its mass would be mass. So you need to find out the mass. So to find out the mass, once again we will apply the formula. Rho is equal to m over v. Rho means the density, which is equal to 2500. Right? So here mass we don't know. Mass we don't know. Volume is given how much? 15. Now you do the cross multiplication, my dear children. So when you do the cross multiplication, if you want, you can do multiplication in here also. But however, you know that when you multiply m by 1, the answer is m. So when you multiply 25 by 15, let's see the answer, how much is it? So m is equal to 25 by 15. So then you put 2 zeros behind it. So 15 times 5, 75, 5, 7 is left over, right? 7 is left over. 15 times 2 is 30. 30 plus over there 7. 37. Then put 2 zeros at the end. So the answer would be 37,500 kilograms. 37,500 kilograms. 37,500 can be observed here. 37,500 kilograms. Triple beam balance is used to measure, very simple my dear children, we use the triple beam balance to measure the mass of a certain object, mass of an object. Right my dear children, then the next question, question number 33. Correct statement regarding the density. It is a vector quantity. So you know that we learned this thing under the force lesson my dear children, basic concept regarding the forces. You know that force is a vector quantity because it has a definite direction and a magnitude. But however, density is not having a definite direction. It doesn't show any direction of acting. So therefore, density is a scalar quantity. So it is a vector quantity, that thing is incorrect, right? It is not a vector quantity my dear children, it is a scalar quantity. So the correct answer for the question number 33 would be, it is a scalar quantity. It always acts towards the ground. It's once again incorrect because there is no certain direction in it. Depends on the gravity, once again incorrect. It is not dependent on gravity. We discussed that thing in the earlier questions, right? Next one. Correct statement regarding the density. Once again, you have to choose the correct statement. It is the ratio between mass and volume. Of course, the first and foremost one is correct. It's a ratio between mass and volume. However, let's go for the other ones as well. It is the ratio between weight and volume. Incorrect. Density of an object changes when cut into small pieces. Once again incorrect. Density of matter is changed when crushed. Once again incorrect, right? You know that even though now by crushing and by cutting into small pieces, we are changing the volume. We are changing the volume, right? We are taking small bit of parts. However, there is no difference in the density, even though you cut those things into small pieces or you crush those things. Okay. Right. Then the next one, question number 35. What can you say about 50 ml of pure water and 50 ml of sea water? So you know that 50 ml of pure water, 50 milliliters of pure water means it contains only water. However, in sea water, you know that there is plenty of salts dissolved. So we can say that density of sea water is greater than the density of normal pure water. Mass of sea water is greater than the normal mass of water, pure water. So let's go for the answers. 50 milliliters of sea water has more mass. Absolutely, this is correct. That should be the answer. We'll see the other ones. 50 milliliters of pure water has more mass. It is incorrect. Both samples have the same mass. No. It's difficult to say about their masses. So our correct answer would be 50 milliliters of sea water has more mass, because in the same volume, my dear children, if they have same volumes, definitely one should have a greater mass, or else those should be in the same substance. Okay. So that's why we measure the thing called density. Density is the mass upon volume ratio. If the volume is same in both substances, right? If the volume is same in both substances, then my dear children, definitely one should have a greater mass and one should have a lesser mass. Here, seawater has a greater mass because it contains several salts. Next one. Special instruments which are made to measure the density of milk. Lactometer, Metrolac, hydrometer, alcohol meter. All of these things are hydrometers. However, special instruments which are made to measure the density of milk is referred as lactometers. Lactometers. Okay. Right. Diagram shows two hydrometers which liquid has more density. So these are two hydrometers. So you have to find out which one has the more density. So it's very simple. If one is having more density, then my dear children, more part of the hydrometer should float. So more part is floating in the liquid A. So liquid A has the higher density. So more density can be observed in A. Which liquid has the lower density then? Liquid C. Liquid C has the lower density it's because that greater part has sunk in the liquid given. Okay. Next one. Special instrument which used to measure the density of rubber latex. Very simple, my dear children. It should be Metrolac. 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 Next one. Most abundant quantity of matter in cow milk is. Most abundant quantity of matter. You know that 90% of cow milk consists of what? Water, my dear children. Water. Then the other components can be identified only in 10%. Right. Density is always dependent on volume of the matter. Of course, it is correct, dependent on the volume. Mass of the matter. Of course, it is once again correct. Mass and volume of the matter. That should be the answer. It depended on both mass and volume. Not only with the mass, not only with the volume, but the both. Right. Seawater has more density than pure water because pure water is a mixture. Incorrect. Pure in the name itself, it is referring to a pure substance. That means it is not a mixture. Seawater contains salts and minerals which dissolves. That should be our answer. There are minerals and salts which dissolve, so therefore it has a greater density. Seawater has less density than pure water. Incorrect, because the question itself says that seawater has more density. Then the pure water contains salts and minerals which dissolve. Once again, incorrect. Right. Question number 43. Select the incorrect answer. Incorrect answer. Okay. In a car battery, density changes when time passes. Correct. In a car battery, right? Car battery means a lead acid accumulator. So in a lead acid accumulator, what will happen? When the time is going to pass by, the density is going to change because the amount of lead which is going to dissolve within the acid is going to change. So in that case, the density is getting changed. By that way, we can find out the health of the battery as well. Next one. Pure water has more density than coconut oil. Pure water has more density than coconut oil. Once again, correct. Even we measured these things in our laboratory. Can you remember? We measured the density of the water. We took that answer nearly as 0.99, right? And we measured even the density of coconut oil, nearly 0.9 something, right? 0.90 nearly. So it's somewhat lesser than the coconut density of coconut oil is somewhat lesser than the density of water. It is correct. Next one. Density of a material could change if volume changes. Density of a material could change when volume changes. We'll keep that thing. We'll go for the other one. When water mixed with milk, density of milk increases. When water mixed with milk, density of milk increases. This is for sure we know that incorrect. Because my dear children, when water is mixed with milk, density of the milk is going to decrease because of reduction in solid substances. More water, less solids. So the density would definitely decrease. Then the previous one is correct, right? Actually, it is correct. You know that density is dependent on only with volume and mass. So when changing the volume, definitely the density should change. So in a gas, my dear children, the density, the volume can be changed by changing the pressure. So that's why it is given as density of a material could change. That means it has a possibility to change when changing the volume. So it is correct. Next one. Alcohol meters are name itself mentioned in the alcohol meters. Used to measure volume of alcohol. Used to measure percentage of alcohol in liquor. Used to measure quality of alcohol in liquor. Used to measure strength of alcohol. So alcohol meters are used to measure the percentage of alcohol in liquor, my dear children. That's the main idea. By checking the percentage of liquor, we can measure the quality and as well as the strength of the alcohol. Okay. Right then. Then the next one, question number 45. Dead Sea has the ability of floating a man without sinking because it contains solid salt crystals. Yes, it contains solid salt crystals, but it is not the answer, right? It is not the accurate answer. Salt concentration in seawater is very high. Density of these Dead Sea is lower than a man. It has less water. So actually, the correct answer is the salt concentration in water is very high. When increasing that salt concentration, my dear children, what will happen? The density is going to increase. So therefore, salt concentration in water is very high. That should be the answer. That should be our answer. Next one. Solid has higher density because volume is high. It occupies more space in the environment. Particles are tightly packed. Therefore, volume is low. Particles are loosely arranged. Therefore, volume is low. So, volume is high. Incorrect. You know that in a solid, my dear children, volume is less. Because of having lesser volume, it has a high density. Why does the solid has or any kind of a solid is having a very less volume? Because their particles are tightly packed and arranged. So therefore, they would not spread here and there. So the answer would be particles are tightly packed. Therefore, volume is low. Right. Then the next question. Metal which is available as a liquid. Very simple, my dear children. A metal which is available as a liquid is mercury, which is having a very high density like 13,600 kilograms per cubic meter. Use of measuring density. Calculate the volume, measure the mass, identify nature of bonds, identify whether the substance is a mixture or else a pure substance. Very simple, my dear children. I told you these things several times. Density is a measurement or else a quantity that can be used to identify whether a substance is a pure substance or else a mixture. So, my dear children, our answer would be to identify whether the substance is a mixture or else a pure substance. Then the next one. Hydrometer is sunk more in a liquid if the density is. So, hydrometer is sunk more in a liquid, more. That means sinking is more. If the sinking is more, then, my dear children, the density of the liquid is less. If hydrometer is sunk more in a liquid, then it is having less density. Next one. When increasing pressure, density of a gas will. When increasing pressure, you know that gas particles can be compressed together. That means, my dear children, gas particles are tightly getting packed. When particles are tightly getting packed, what will happen? Volume would reduce. When reduction of the volume happens, density will definitely increase. So, density will increase. Right? Density will increase. So, we have discussed 50 MCQ questions regarding the lesson. Right. So, let's head on to see what are the other contents. Right. So here you are given with a question, write the correct answers. Describe the meaning of density in brief. The meaning of density in brief is, density is the mass contained or mass contained in unit volume of matter. So density is the mass contained in unit volume of matter, right? Density is the mass contained in unit volume of matter. This is what do you mean by the density, my dear children, or else mass in unit volume of matter. Next one, define two units to measure density. So the two units to measure density, number one, kilograms. Kilograms per cubic meter. Kg m to the power -3. Kilograms per cubic meter. Kg m to the power -3. Number two, grams per cubic centimeter. Kg cm, sorry, not kg, it should be grams, right? So g cm to the power -3, right? So the two units to measure density, kilograms per cubic meter, kgm to the power -3, grams per cubic centimeter, g cm to the power -3. Right. Name two special types of hydrometers and their use. Two special types of hydrometers. Number one, lactometer. Lactometer, used to measure density of milk. Used to measure density of milk. Number two, Metrolac. Used to measure density of rubber. Right. So two special types of hydrometers. Lactometer, used to measure density of milk. Metrolac, used to measure density of rubber. Okay, two types of special hydrometers. Next one, what is the international standard unit to measure density? The international standard unit to measure density is kilograms per cubic meter. Kilograms per cubic meter. Right, kilograms per cubic meter. In brackets I'll include kg m to the power -3. Kilograms per cubic meter. Kg m to the power -3. Right. Then the next one, question number 5. Arrange the given in ascending order of their density. Ascending order of their density. That means from lowest one to highest one. Okay. From to the ascending order. Right. So let's see the ascending order. Water, ice, mercury, kerosene, oil and gold. You know that the kerosene oil is having the least density, right? Kerosene, right? Kerosene oil. This one is having the lowest density, kerosene oil. Then water, ice, mercury and gold. After kerosene oil, my dear children, ice and water, which one has the low density? You know that ice is floating in water. If you have prepared fruit juice or cordial, if you added ice into it, you may have observed that, right? When adding ice crystals or ice into water, ice will definitely float. Even in the previous questions, can you remember, icebergs are even floating in water because ice is having lesser density than water. So ice should be the next one, then water, right? So kerosene oil having the least density. Ice has even more density than that, and water has even more density than the ice. Then we have to select the last two, mercury and gold. Actually, my dear children, gold is having the highest density from these all. Okay, so next one would be mercury, then the densest one would be gold. So this is the order, the ascending order of density of the substances. Find the relationship between kgm to the power -3 and grams per cubic centimeter. Let's see. That means you have to convert kilograms per cubic meter into grams per cubic centimeter. Let's see how to convert this thing. We know that 1 kilogram division 1 cubic meter is equal to 1 kilogram per cubic meter. Now what I am going to do is, I am going to convert this kilogram into grams. You know that when you convert kilogram into gram, or 1 kilogram is equal to 1000 of grams. 1 cubic meter, now we need to convert 1 cubic meter into centimeters. Let's convert. So I'll take the slide even more somewhat up in order to show the relationship, my dear children. 1 cubic meter is equal to 1 meter into 1 meter into 1 meter. Can you remember the cube that we used to define the density? So we found out the volume by multiplying length, breadth and height, which is equal to 1 meters each. So here 1 cubic meter is equal to 1 meter, 1 meter, 1 meter. Now you know that 1 meter is equal to hundreds of centimeters. 100 centimeters. Again 100 centimeters. That means altogether 1, 2, 3, 4, 5, 6. So 1 cubic meter is equal to 1 million of, right? 1 million of 1 cubic meter is equal to 1 million of cubic centimeters. Now let's go for the other thing, right? So it is equal to 1 million cubic centimeters. Now let's divide and get the answer. 1 million. Right? Here 1000. 1000 over 1 million. Then here grams here cm to the power 3. So when you divide the zeros, you can clearly see the relationship, my dear children. The relationship is, I'll use another different color pen to write down the relationship. See? Here 1 over 1000. 1 over 1000 can be seen. So 1 kg m minus 3 is equal to 1 over 1000 gcm minus 3. So 1 over 1000 gcm minus 3 is equal to 1 kg m minus 3. The relationship between kilograms per cubic meter and grams per cubic centimeter. In simple, we can introduce this thing like this. So you can multiply both sides by 1000. In that case, you can get the answer as 1 gcm minus 3 or else 1000 right. When you multiply both multiply by 1000, you can get 1000 gcm minus 3 is equal to, right, 1000 of gcm minus 3 is equal to 1 kg m minus 3. That means if you want to convert given gcm minus 3 values, grams per cubic centimeters values, to kilograms per cubic meter values, you just multiply by 1000. Okay, you just multiply by 1000. By multiplying from 1000, you can convert that thing. So I'll erase this thing. This is the original one. You can substitute that thing to each and every place that you want. Okay, so 1 over 1000 gcm minus 3 is equal to 1 kg m minus 3, right? So when you are going to divide 1 kg m minus 3 by 1000, or else when you divide kilograms per cubic meter by 1000, you can get the grams per cubic centimeter values. Or else when you multiply grams per cubic centimeter values by 1000, you can get the answer in kilograms per cubic meter values. Okay, you multiply this one by 1000 in order to convert into that thing, or else you can divide this one by 1000 in order to convert into this thing. Okay, right. So this is the relationship. Next one. Given below are 3 states of matter. Name these states and explain what happens with the density. So this is given how the you can observe the 3 states of matter. Here it is given the particle arrangement, my dear children. The particle arrangement can be observed in these 3 figures. Here particles are tightly packed. Here particles are somewhat loosely arranged. Over there particles are very loosely arranged. That means this one definitely should be a solid, tightly packed particles. This one should be a liquid. And the final one, which is over there, should be gas. It should be gas. Now let's explain the density. So here the density is very high because particles are tightly packed. Density is high as particles are tightly packed. Then the next one. Here the density is lower than solid, density is lower than solid but higher than gas. So according to the particle arrangement, as you can see, the gap between particles is somewhat greater than solids, so therefore density is lower than solid but higher than that of a gas. Then the third one, gases, density is low because particles are not tightly packed. Right. So density is lowest because particles are not tightly packed. So these are the three states of matter, and according to the arrangement of the particles, how the density is going to change. So in a solid, density is very high because particles are tightly packed. In a liquid, density is somewhat lower than solid but greater than gas. But in a gas, density is the lowest because particles are not that much tightly packed. Okay, they are loosely arranged. Particles are loosely arranged. Right, then the next question. Write 5 uses of hydrometers. 5 uses of hydrometers. So very simple, my dear children. Number 1, used to measure or used to get composition of soil. Used to get composition of soil. We can use hydrometers to get composition of soil. Number 2, to measure, or else we can say to get the check the quality of cow milk. To check the quality of milk. To check the quality of milk. Next one, number 3, to check the condition of batteries. Right? To check condition of batteries, within brackets I'll include lead acid accumulators. Right? Next one, to measure the density of seawater. To measure density of seawater. To measure density of seawater. Then to measure density of, or else quality, right, or the percentage. To measure percentage of alcohol, right? To measure percentage of alcohol. in alcohol drinks? So these are the uses, my dear children, used to get composition of soil, to check the quality of milk, to check the condition of batteries, lead acid accumulators, to measure density of seawater, to measure percentage of alcohol in alcohol drinks. These are the uses of hydrometers, my dear children, hydrometers. Next one. Mention the use of measuring density in matter. Use of measuring density. You know that by measuring the density, we can check whether a substance is a pure substance or not. So our answer is quite simple. We can get an idea. We can get an idea whether the substance is pure or not. To check whether a substance is a pure substance or not, we can check the density. Okay, so we can get an idea whether the substance is pure or not. Right. Final question of the second question. Arrange the given gases according to the ascending order of their density. Ascending order of their density. Ascending order means from lowest denser one to highest denser one. Hydrogen gas has the lowest density. Then, my dear children, oxygen gas. The highest density, the heaviest one of all, is carbon dioxide gas. Carbon dioxide gas. So these are the three main gases that we are going to study in ascending order of their densities. So the highest density can be observed in carbon dioxide gas, my dear children. Lowest density can be observed in hydrogen gas, and the oxygen gas is intermediate. Okay, greater than hydrogen. It is having a high density greater than hydrogen, but my dear children, less than the carbon dioxide. Okay. Right, my dear children. So with that part, we have discussed several types of questions, several essay type questions related to the lesson part with several MCQ questions. So in the next chapter, we'll be discussing even more questions related to the density lesson. So stay with me till the end of the lesson. So in the next chapter, my dear children, in our next chapter, I'll be discussing even more questions related to the density lesson. Then after that, we'll be winding off the lesson. Okay, so I'll hope to meet you guys with our next chapter to discuss even more questions.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.